Hi everybody, my name is Murat Aydın. Today I'm talk about battery optimization for Android apps. Let me give a brief info about me. I'm an Android developer and blogger in my free time. I'm working as a senior software engineer at STM. I am GDG Ankara member and we are organizing Android Developer Days and I'm inviting you to this event. So why battery is important? It's important because it's the main and limited resource for the device and user may need it to perform an important action. It's also important because it's part of user experience. Your app may have material design, may have a great performance, great user interface, but if your app drains battery, user will just uninstall it. And you may get bad reviews or ratings if your app drains battery. And also some companies like Verizon list applications that drains battery as high-risk Android apps. So here is my super advices that completely solve the battery problem. You can buy extended batteries, you can buy case batteries, and my favorite one is Trepn reactor that charges devices for 50 times. Now let's see some real stuff. What consumes most? Initially, when the device is in airplane mode or idle state, it doesn't consume much. It starts consuming when the screen turns on. Approximately 90 milliamps is consumed. Then CPU, game sensors, GPS radio, and network components like Wi-Fi, 3G, and edge connection is added on it. And network components consumes the most. Now you see some usage measurements for a 1150 milliamp hour capacity battery. You can watch YouTube videos for 3.4 hours with this battery. The power goes to screen, networking, and video decoding. And with this battery, your device can stay in airplane mode for 24 days. And now you see a bulk data transfer for a 6 megabyte song. You see that Wi-Fi consumes 330 milliamps, but in total it consumes least because it's speed, so you can prefer Wi-Fi for bulk data transfers. An interesting info comes from a research made by Purdue University. They found that some famous applications games like Angry Birds, 75% of their battery power goes to user tracking, uploading user information, and downloading ads. So you should be careful about choosing your user analytics SDK and also third-party libraries that you use in your app. Now you see the 3G radio state machine. It's important to understand this state machine because you can optimize your Android apps if you know this better. Initially, the 3G radio is in standby mode. When there's a network connection, it passes to full power state. It finishes its job, then it stays 5 seconds in this state, then it passes to low power state. It also waits here for 12 seconds. Then it passes to standby mode. Now you will see the effect of this state machine here. Suppose there are 3 data transfer, each lasts for 3 seconds in every 20 seconds. One data transfer lasts 20 seconds, 3-second data transfer plus 5 seconds for full power idle state and 12 seconds for low power idle state. But if we bundle them together, 3 of them, the total transfer lasts 26 seconds. You see that half of the unbundled version, and you save battery if you bundle them. Now let's see some tips for better battery. You can prefetch the data that your app uses. This will reduce your download times. It will minimize the in-app latency because you don't do downloading. But you should be careful about it because if you do it aggressively, it will also drain battery. You should prefetch data such that user will need another download in 2 or 5 minutes. You can batch the data that you want to transfer. You can send them into a queue, and later you can bundle them and transfer in one connection. You can use Traffic Stats API. It comes with the framework. You can take the threads that do networking. Then in the DMS tool in Android Studio, you can see the network activities of your application. You can detect the unbundled transfers. Then you can bundle them and you can save battery. So polling is checking the server for an update. You can use Google Cloud Messaging instead of polling. The server will send a message to the clients in case of an update. If you need to do polling, you can use inexact repeating alarms. This will also save battery, and you should be careful about using wake-up versions of the alarm, because waking up a device is a dangerous thing for the battery. Some other apps that waste the device to be awake may also start updating. So this will trigger an update of the other apps. And also in polling, you can use exponential backup pattern. If there isn't any update, you can increase the interval that you check the server. Cache data as much as possible. This will also save battery, but be careful about displaying stale data. Put an expiration date for your data. And you can also monitor the connectivity. Avoid network connection attempts if there isn't any network connection. And you can modify download pattern according to the connectivity type. For instance, you can prefetch aggressively it is connected to Wi-Fi. Compressed data before transferring, especially textual data compressed well. You can use gzip input stream that comes with the framework. It's very easy to use it, so you can compress data for better battery. You see the effect of compressing, especially in edge connection. Its effect is dramatic. You can monitor the battery level and battery state. If your device is connected to wall charging, you can prefetch aggressively. For instance, if your device is in low power, you can reduce the update frequency of your app. This will also save battery. Wakelock is a mechanism that keeps the device awake. You should be careful about using this API, because in Android documentation it's also indicated that it's dangerous for the battery. So you should be careful about using this API. Instead of Wakelocks, you can use keep screen on tag in your layouts. This will acquire the Wakelocks on behalf of you, and when your job finishes, it will release it on behalf of you. You can use efficient data format and parsers. For instance, you can use event and stream-based data parsers. They are better for battery, and you can also prefer JSON or protobuf. Protobuf is a binary data format. If your Android application doesn't need high accuracy, you can use coarse network location, because it is better for your battery. GPS radio consumes more than network location. Now I want to introduce you Trepn Profiler. It's developed by Qualcomm. It's an Android APK, and you can profile your Android application with this profiler. You can see some statistical info, charts about your battery consumption. It also supports scripts, so you can use it in automated tests. It also have an Eclipse plugin, so you can profile your app through Eclipse. And they are also developing a plugin for Android Studio, so later you will be able to use it in Android Studio too. Now we will see a demo of this profiler. In the settings, you can change your preferences. It's better to select acquire Wakelock while profiling for a better statistics. In the data points, you choose the data points that you want to collect during profiling. I choose battery power. You can choose CPU. And also I choose mobile data state. And you can enable overlays that you want to see during profiling. Here I enabled battery power and mobile data. Now we start profiling app. You can also profile the system also. Here we profile an application called Butterfly TV. It's a live broadcasting application. Now you see the overlays on the left-hand side, battery power and mobile data. Now we start recording. As you see, battery power consumption increased. And now we stopped profiling, stopped recording. And save the session to a file, DB file. And now we load the DB file. Here, now we open the profiling data. You see the charts here, legends. Red one is the battery power, yellow one is the mobile data, and blue one is the application state. In application state, in your source code, you send some intents, Android intents. So the Trepn Profiler receives these APKs and you can change application state with these intents. I send intent in start recording and in stop recording. On the right hand side, you see the legends. Now you see the application state. As you see, between them, the battery consumption increased because there's a network connection here. User sends data to the server. Now you can enable and disable the legends. There you can also see some statistical info about your profiling. Now we closed. Now if you follow these steps, as a result, you may make the day with a 20% battery left. Thanks for listening. If you have any questions, you are welcome. Okay, thank you.